In this chapter, we are going to completely switch gears and start talking about something that is called linear regression. Now, a lot of times mathematicians or statisticians or scientific researchers, they want to find a relationship between two quantities and express it as some kind of equation. And there are so many different equations out there, so many different ways to do this, so many different functions. However, what we're going to focus on is linear functions, and we're going to come up with equations of lines. But keep in mind while we're doing this, there are other functions out there that you can use to model the data. Now, there's something called a least squares regression, which is basically a method that's used to find the line that minimizes the distance between the line and all the points, and therefore getting the line that comes the closest to all of those points. And that's where we come up with that linear regression method. There's a way we can do it by hand, which is very tedious and a lot of formulas. It's not necessarily hard, but it takes a long time. But you can do this on the calculator, which is what I'm going to show you how to do. But what I want you to focus on is the idea of what the calculator is doing. When the calculator finds that line for you, it literally is finding the line that comes closest to all those points. Now, before we get into the actual calculator method, I want to review linear equations with you, so then when you find the line, you know how to manipulate it and to use it appropriately. Okay, so the first thing we're going to review is independent variable versus dependent variable. And the independent variable is our x, or our input. The dependent variable is our y, or the output. So typically when we look at some mathematical equation, for example, y is equal to 3x plus 2, if I say x is equal to 3, find y, we put x in, so we have 3 times 3 plus 2, and that will give us our y value. That's why we call x as the input, because we're plugging it in, and then y is the output. It's what we get out, the corresponding value of y. So that would give me that our y is 11. So y is dependent on what we plug in for x. Now these values here will be constant, but the variables will change depending on what you plug in. So I'm highlighting our variables in pink, and the blue is constant, will always remain 3 and 2. Okay, now the slope of a line, let's talk about that. So when you graph linear equations, you'll see that the line has some kind of a tilt. It will tilt up if you read it left to right. It might tilt down when you read it left to right. And some might be steep, some might not be so steep. The measure of the steepness and the direction of the line, how we measure that, that's called slope. That's the steepness and direction of the tilt. Now, there's 4 different possibilities you can run into with a line. You could have a line that looks like this. So when I read that line and I trace it going left to right, it goes up. That means it's a positive slope. Now, if I read the line left to right and it goes down left to right, so as I trace it with my finger, it goes down left to right. That's a negative slope. Now, there are two other cases that you could run into. The negative slope and the positive slope are the most typical or the most common, but you could run into some special cases where you have a slope that's 0, so it has no tilt, or you could have a slope of a line that is undefined. Going up and down, where you have a vertical line straight up and down, this is called an undefined slope. Now, the concept of slope in real life is going to represent some kind of rate, which is where the two quantities come in. You want to see how one quantity changes with the other. It's the ratio of the change in y to the change in x. So, when we write the equation of slope, it's the change in two values of y over the change in the corresponding values of x's. That's going to be our formula, and this is hopefully all coming back to you. But in real life applications, remember this represents some kind of a rate, like dollars per hour or miles per hour. Now, with the y-intercept, it is literally where the line crosses the y-axis. That's why it's called the y-intercept. If you forget which one is the y-axis, the vertical axis is the y-axis and the horizontal axis is the x-axis. So when I graph some line, the value right here where it crosses the y-axis is the y-intercept. When you write it as an ordered pair, your x, y form, for the y-intercept, your x is always going to be 0, because at this point right here, my value of x is 0, and then you're always going to have your y value is going to be where it crosses on the y-axis. And a lot of times that's labeled as b, but this will be where it crosses on the y-axis. And don't forget, when you write it as an ordered pair, as x comma y, your x is always 0. And then your b is this value here where it crosses the y-axis. So if this was 1, if I made my dashes 1, 2, 3, then in this case my b would be 1. Now, when we put this all together, our general form that we're going to be using is y equals mx plus b. The calculator, this is what we generally use in books. This is what we usually see in books. The calculator actually uses ax plus b. But just be aware that the a is the slope. The number that's in front of the x is your slope. So let's write that down. M or a, depending on the notation, is going to be your slope. So that's going to tell you the tilt of the line and the direction. Okay, and b tells you where it crosses the y-axis. Now, in real life, we said for the slope in real life, that was going to be represented by a rate. In real life, typically, your b or your y-intercept is your initial value because it's your starting point. It's your starting point. When x is 0, what are you starting at? What's your value of y? So this is what b typically means when we're talking about it in a real world application. So I've got two examples I'm going to walk through with you and review linear equations. So in the first example, it says Amy tutors to make extra money for college. For each tutoring session, she charges a one-time fee of $25 plus $15 per hour for tutoring. Now, here is our rate. It's $15 per hour. Another way to write that, per means divide, or you can write it as a fraction bar. So another way you can write it looks like this, $15 per 1 hour. That's our rate. Now, even when she does 0 hours of tutoring, just to meet, she has a one-time fee of $25. So that's going to be my value B. So no matter what, just for her to show up to meet with you to tutor, she's going to start you off at $25. And then after that, she's going to charge you an additional $15 per hour. So 25 is your initial value, your starting point. So that's going to be your value of B. Now, what's the independent and dependent variables? Now, one way you could tell, sometimes in the question it will say, this quantity depends on this quantity. And when it directly tells you that, it's easy to pick out. However, when it doesn't directly say that, you can pick it out by looking at the rate. If you notice, dollars are on the top for the rate and hours are on the bottom. And remember, our rate or our slope is the change in y over the change in x. So our dependent variable, which is our y, is the dollars, and our independent variable, which is our x, is the hours. So I'm going to write this down as the dependent is the dollars, and then the independent is the number of hours tutored, which makes sense because when you go to pay Amy for tutoring, she's going to calculate her dollar amount that she's going to charge you based on the number of hours tutoring. So the cost depends on the number of hours. Now we're going to find the linear equation. Our basic equation that we're going to use, this is called the slope intercept form of the equation. So looking for our equation, we need to leave x and y as x and y so that we can plug values in and find the corresponding y value, but we do need to put in what our slope and our y-intercept values are. Our slope is our rate, which was given to us as $15 per hour, and our initial value is 25. That's our B. So there's the equation of the line. And now, since we have that set up, we can use that to find different costs depending on the value of x. So for example, if I said I wanted to find the cost for 1 hour of tutoring, I would say x is the number of hours, so I would plug in 1 hour for x, and I can find my corresponding value of y. So I would take 15 times 1, which is 15, and add 25, and I would get 40. So for 1 hour of tutoring, it would cost $40. Okay, now it says, what is the y-intercept and what is the slope? Interpret them using complete sentences. So the y-intercept is $25 because that is the cost at x equals 0 hours. Now the slope is the rate in dollars per hour for Amy's cost to get tutored. Now, I already pre-graphed this and loaded it in because I have horrible drawing skills. But what you need to keep in mind is when we graph our equation, there's two ways that we can do it. The first method is to look at our starting point, which we said was 25. So that's our value of b, where it crosses the y-axis. So this should be where it crosses at 25. And then we use our slope of 15 to create more points. And then we can connect the dots or the points with a line. So my slope is for every hour, and our x is our hours. So I'll put hours here. This is our y, which is our dollars. Here's our y-axis. Here's our x-axis. For every hour, it's going to go up $15. So if I come over 1 hour, I'm going to go up 15. Then if I go another hour and do another hour of tutoring, I come over to 2 hours, I have to go up another $15. So I'm going to make these steps, and then I can connect all those points, which forms my line. So that's using the slope and the intercept to graph. Now the other way you could make your line is by making what's called a t-table. Just make a table of x's with the corresponding values of y. So since our equation is y is equal to 15x plus 25, I'll start with I'll make some points 0, 1, 2, 3. You can pick whatever points you want. I'm going to pick the point 0, 1, 2, and 3. So I would plug in 0 for x and find my corresponding value of y. When I plug in 0 for x, I get 15 times 0, which is 0, plus 25. That gives me 25. When I plug in 1 for x to find my corresponding value of y for x equals 1, I get 15 times 1, which is 15. And then I add 25. That's going to give me 40. When I plug in 2, I have 15 times 2, which is 30. And then I add 25. That's going to give me 55. When I plug in x as 3, I get 15 times 3, which is 45. And when I add that to 25, that's going to give me 75. So once I have some points, I can plot my XY points and then connect them with a line. So if I go ahead and do that, if I plot 0, 25, that's this point right here. Then I plot the point 1. So I come over 1 and I go up to 40 for Y. That's this point here. Then I'm going to plot the point 2, 55. So I come over to X is 2 and go up to 55. And then for x is 3, come over to 3, I go up to 75. Then you can connect all of those dots or all of those points and you get your line. Okay, let's look at our second example. Ethan repairs household appliances like dishwashers and refrigerators. For each visit, he charges $25 plus 20 hours per hour of work. So here is our rate that's given to us, $20 per 1 hour of work. So this is going to be our slope. And remember, our slope is the change in y over the change in x. So that will help us determine what our independent and dependent variables are. So for our dependent, that's our y value. So that's going to be the dollars. For the independent, that's our x. So that's going to be our hours. And when you think about it, the dependent value, which is the dollars, depends on the number of hours that is worked. So now we're going to find the equation of the line. So we want to leave our y and our x in those positions, but we want to find what our value of m and b are so we can plug them in and form our equation. So we said our rate, which is our slope, is our $20 per hour. So m is going to be 20. And our b, which is our initial value, that's going to be 25. Because just for walking through the door, he charges $25, and that's before he even starts to work. So that's going to be your initial value. What is the y-intercept and what is the slope? Our y-intercept is $25 because it is the dollar amount when x is equal to 0 for hours, when x is 0 hours. Now the slope is $20 because that is the rate in, now the slope is 20 because the rate is $20 per hour. Okay, so the equation of our line is y is equal to 20x plus 25. So if I graph this by finding the y-intercept first, which is my 25, that's going to be my starting point. X at b is equal to 25. And then I use my rate, which is 20 over 1, or $20 per hour. So my x-axis is going to represent the hours, and my y-axis is going to represent the dollars. So every time I come over 1 hour, I'm going to go up $20. So I'm going to go from 25 to 45. That's a change of $20. So I'm going to come over again 1 hour, and I'm going to go up 20. So this is 20, this is 1. This is 20, and this is 1. Now, if I do this using XY points, if I plug in 0 to find my corresponding value of y, 20 times 0 is 0, and when I add 25, that gives me 25. When I plug in 1, that's going to give me 20 times 1, which is 20, and 20 plus 25 is going to give me 45. When I plug in 2 to find the corresponding value of y when x is 2, I get 20 times 2, which is 40, and then I add 25, and I would get 65. So when I go to graph these points, it will form my line. So I get the point 0, 25, that's this point here. Then at 1, I come over to 1, and I go up to 45. That's here. Then at 2, I come over to 2, and I go up to 65. And then when I connect those dots, I get my line. So when you go to graph your line, you can pick which method you'd like to use, but you should also be able to, if you're given the graph, do it in reverse. You should be able to identify what the slope is by finding 2 points on there and see what the change in y is over the change in x. That's this here. So every time I come over 1, I go up 20. I come over 1, I go up 20. So that means my change in y over my change in x will be 20 over 1, which is 20. So you should be able to identify that from the graph, and you should also be able to identify your y-intercept by looking to see where it crosses the y-axis. In this case, my b is 25, because it crosses the y-axis at 25. So you should be able to identify those two things when you're given the graph, as well as draw the graph.